So here they're asking you a youth group of 8 boys and girls. A youth group has 8 boys and 6 girls, right? If a slate of 4 officers is selected, find the probability that exactly 3 are girls, 2 are girls, or 4 are boys, right? So basically, this is a hypergeometric distribution, okay? And hypergeometric distribution. And to make it simple for you, I'm gonna go to the slide just to review what's that for you. Okay, here. So what they say about the hypergeometric distribution. The hypergeometric distribution is a distribution of one variable. So we have the random variable x in this case that has 2 outcomes when sampling is done without replacement. So once you take it back, you don't put it back, right? That's without replacement. With replacement means you put it back, right? So here they said, given a population with only 2 types of objects, right? Females and males, or like the problem, they have boys and girls, defective and non-defective success and failure such that there are A items of one kind and B items of another kind, and A plus B equals the total population, that the probability of P of X of selecting without replacement a sample of size n with X items of type A and n minus X items of type B is this PMF, right? So let's go back to the problem and let's try to solve it based on these definitions, right? So here a youth group has 8 boys and 6 girls, right? So this is the type A that they're talking about. This is the B, right? If a slate of 4 officers is selected, so this is a sample size, or N, right? Find the probability that exactly 3 are girls. So this is X, right? This is little x. So the probability of X is what? A, choose N, I'm sorry, X. And then B, choose N minus X. And then we have the population, which is in this case, A plus B is the population, right? A plus B is the population N. So I'm gonna put N. And then N is just the sample size, right? So here, the only thing I need to do is just find out what's A, what's B, right? So A here is 8, to make it simple. A is 8, B is 6, sample size N is 4. The population is A plus B, which is 14, right, in this case. So you just need to substitute. So 8, choose X, and in this case, X is 3, right? Probability of X, exactly 3, right? So this means this is 3, right? So exactly 3. So this is A, choose 3, right? Actually, here I have to be careful. 6, choose 3, right? Because 6 are girls and 3 are selecting, right? And then the boys, let me put this clearly for you. So A is 8, right? And since we're selecting 3 girls, so that means that 1 can be boy. And then 6, choose 3, like they say here. 6 girls, choose from the sample size, or from the 6 girls, you choose 3, right? And from 8 boys, you choose only 1. And then the population here is 14. And then the sample size is 4. So this is calculator from this point, right? You just need to put it in the calculator and you're done. So this is combination, right? You put in the calculator and that's it. We don't have a direct way to do this with a calculator like the binomial or the Poisson. So we have to do basically one by one, right? But that's not difficult. Give me 1 second. I want to use the calculator really quick. Yes, now I can use it. Okay. So again, you choose. Give me 1 second. Okay, so now we have the combination, right? So we have to go to math. And before we do it to math, let's put 8, because 8, and then we go to math, and then the probability here. And here is this value. So N, choose right? 1, and we get that value, whatever that is. In this case, will be 8. And then you do, now this time, instead of doing that again, we can do this again, and then we change the values. That's it. So this is 6, choose 3, and you multiply that, whatever that is, right? And not multiply, but you do the combination, right? And then you do again that same thing. You do again, and this time, oh, I'm sorry, I have to do here. I have to delete this. I have to choose that, and I need to change this, right? So this time is 14, choose 4. Oh, what happened? Okay, 14, choose, why did you get to do it? Okay, let me do this one now. 18, because this has 2 values, that's why. I have to do it from scratch, this one. So math, I have to go to before I put math, I need to put 14, then math, probability, and then I need to choose 3, and then I can choose 4 this time. Okay, so this is the denominator, just keep that in mind. So I need to multiply the numerator, which is 8 times 20, and divided by that number, right? This, let me put this in parentheses so I don't confuse you. So this is this 8 times 20, and then this divided by this value, and I should get my answer. So I get 0.1598. Okay, so that's the answer for the first one. So let me go back to the slide so you can understand what I'm doing. What happened? Okay. So this is what I did, right? I choose A, is 8. This represents the boys. And since there's 3 girls, from the sample of 4, we're choosing 3 girls. So remember, 8 are boys. So what's left over from the sample of 4 is 1, right? And then from the 6 girls, we're choosing 3 based on this, the probability that exactly 3, right? And then we have a population of 14 and a sample of 4, right? So that will be your denominator based on the hypergeometric distribution, right? That's how you do that. So let's do the rest, and you can calculate the probability from your calculator. I think that will be easy for you. So then the next thing I have to do is now this time, right? Now I have to do this, 2 girls. So I'm gonna write the probabilities, and then since I show you already how to do it in the calculator, you can do it by yourself. So first, it was probability of X, choose 3. So this PMF, choose 3 means A, and this, well, let me write the function here, the PDF, the PMF here, okay? So this is the PMF, f of X equals A, choose, in this case, I choose X, and then B, choose N minus X, and then this is C, and then you choose the population, N, big N, right? And small n, right? That's the PMF. Now, remember the combination, you know what it is, right? Combination A, choose B. This is the same thing as this, right? So that means whatever the value is that you just, actually, let me put the original way that they provided this. This is the same as n choose r. So this is n factorial, n minus r factorial, right? That's for the combination, that's the formula. But you can use the calculator as I show you in the video before. In the calculator, you need to do this thing, right? Okay, so going back to this, so we have what? From 8 boys, we choose only 1. From 6 girls, we choose 3. And then the population is what? Population is 14, and the sample size is 4. That's the first one, right? And then you do this calculation and you get the answer for the first one. For the second one, let me put that in different color. So for the second one, we do the same thing. A is A, right? And then from A boys, we're choosing, from a sample of 4, we're choosing 2 boys. And then from 6 girls, we're choosing 2 girls. And the population is what? The population is 14, and the sample is 4, right? And again, you do the same thing. So that will be F of 2, which is the probability of X takes on 2, right? Exactly 2. This is a hypergeometric distribution. And then the next case will be this one right here, right? 4 boys. What that implies? That implies that from 8 boys, I'm choosing 4. From 6 girls, I'm not choosing any of those girls. And then from the population is 14, and the sample size is 4, right? So, and again, you do the same thing. You put that in the calculator and you get your answer, right? And that's it. Whatever that is, you just do it in the calculator, okay? And if you want to get the exact answers, just in case you need the answers, let me see if I think I did this already. Yeah, give me 1 second. Let me see if I can. Sorry. Let me see if I got that. Okay, so 0.16, then B is 0.42, and C is 0.07. So this is what you're supposed to get, okay, for this probability. So this is 0.16, 0.42, and 0.047, or 0.07, I'm sorry. Okay, next. So this is about the second one is a multinomial distribution. Let me erase this stuff for you. Okay, so they say here income tax errors, the probability that a person will make 0, 1, 2, 3, or I'm sorry, 0, 1, 2, or 3 errors on his or her income tax is 0.50, 0.30, 0.15, 0.05 respectively. If 30 claims are selected, find the probability that 15 will contain 0 errors, A will contain 1 error, 5 will contain 2 errors, and 2 will contain 3 errors. So what you need to do is, this is a multinomial distribution, right? Because this is the generalization, let's say, of the binomial distribution, because in the binomial distribution, we have only 2 outcomes, success or failure, but here we have multiple outcomes, right? Sort of, or more than 2, right? Here we have 0 mistakes, 1 mistake, 2 mistakes, 3 mistakes, right? And so on, and they give you the probabilities, right, of those outcomes, right? Or those events. They say the probability of you make no mistake, the probability of making 1 mistake, and so on, right? So you have to use the multinomial distribution, right? You have to read that section a little bit so you can understand what they're talking about. So I'm gonna go to the slide really quick so you can understand what I'm doing. So here, let's see, where is that? The multinomial distribution is here. So here they describe it really quickly. The multinomial distribution is similar to the binomial distribution, but has the advantage of allowing one to compute probabilities when there are more than 2 outcomes. That's basically what I said before, right? So this is the PMF, right? The probability mass function of that. So the binomial distribution is a special case of the multinomial distribution. That's what I said before. You know about that. So let's go back to the slide and solve the problems. Okay. So the PMF, P of X, is n factorial x sub 1 times x sub 2, x sub k factorial times p1, x1, p2, x2, p3, x3, pk, xk, right? So that's the the multinomial distribution. The only thing I need to do is use the PMF and solve the problem, right? So the first question is asking you, let me move this somewhere else. Let me change the color. Let me put that in red so you can see what I'm talking about. So the first question is asking me, if 30 claims are selected, find the probability that exactly 15 will contain 0 errors, A will contain 1 error, 5 will contain. So what I need to do is the probability here, if 30 claims, right? So here I have to do 30 factorial, 15 factorial, A factorial, 5 factorial, and 2 factorial, right? Because that's 15 will contain 0 errors, 8 will contain 1 error, 5 will contain 2 errors, and put that in blue, 2 will contain 3 errors, right? So basically, I'm using the first numbers, right? Because that's the probability that 15 claims will have 0 errors, A will have 1 error, 5 will contain 2 errors, and 2 claims will contain 3 errors, right? So these are the claims, and the formula says P1, the probability. So the probability of 15 claims will have 0 errors will be 0.50 to the x1 power. So x1 is here 15, and then here you will have to do the next probability will be 0.30, and that's the claim of the A claims will contain I'm sorry, the probability of A claims will contain 1 error is 0.30 to the A power. And then you have 5, right? So 5 claims will contain 2 errors, the probability 0.15 to the power of 5, right? Basically, you're writing these numbers here, right? As you can see. And then the next probability will be 0.05. And they said here that 2 will contain 3 errors. So that means 2 claims, the probability of 2 claims contain 3 errors is 0.05. And this is to the second power. And now you just need to multiply these values and just get your answer, right? You will have to do this by hand too, as well, right? But this is not difficult. You have the calculator, and that will help you out solving this, right? If you want me to do it, I can do it for you, no problem. Let me show you how to do that. Okay, so you will have to say, well, I have to do, here I have, that's a little big number, right? So let me put this in parentheses, 30 factorial. So you go to math and you go to probability, and here you have factorial. So you choose that. So you close it, divide it by, and now you need to put the values, right? 15 factorial, and that's number 4, 15 factorial times A factorial. So I can actually, let me see if I can copy that, enter. Hopefully I can copy that. I can't. Okay, I need to copy this thing. So let me see if I can erase the one on the top now. Clear? Yeah. Anyway. Okay, let me see if I can clear that out, because then after that, that's getting confusing for you guys. Okay. Okay. So now I have to use, let me see, A factorial, math, factorial. Here that's 4. Again, times 5 factorial. That's 4 times 2 factorial. This is right here, math. That's 4. Okay, so that's the numerator and the denominator. So you get, as an answer, you get this little number. So now I need to multiply this number times 0.50, the probabilities, remember? The probabilities times the claims, or to the power of the claims. So this is 0.50 to the power of 15, and then times 0.30 to the power of 8. Those are the claims, times the probability of 5 claims. So 15 to the 5. Oh, what happened here? Second. I don't know why this thing did this thing. Okay, so the 0.3 to the 8 power times, and we have 0.15 to the 15, 0.15, the probability of 5 claims, times the probability of 2 claims is 0.05 to the second power. So now you need to multiply this times this thing right here, and whatever the number is, that's your probability, right? So that's the probability. The probability, if 30 claims are selected, find the probability that 15 will contain 0 errors, 8 will contain 1 error, so that's the probability. Probability is 0.008 if you want to round, right? So that's it. A little long because we have to do this by hand, right? Manually, that takes a little time. Let me share with you what's going on here. And so that's that problem, okay? That's problem number 6, I believe, from the 4. 1 second. Check. Okay. Okay, the next number. This one. So this one I think is going to be easier. So here we have a sport score hotline calls. Sports score hotline receives on average 8 calls per hour requesting the latest sports scores. The distribution is Poisson. So they're telling you what distribution it is. For any randomly selected hour, find the probability that the company will receive at least 8 calls, 3 or more calls, at most 7 calls. So this is a Poisson distribution. So the random variable follows a Poisson distribution. And the only parameter that the Poisson distribution has is lambda, which is the mean or the average in this case, right? So you need to know the PMF, right? So the at least 8 calls implies this, right? At least 8 calls. So this implies this, at least 8 calls means you can use the complement in this case, right? It's going to be long anyway, because they're asking you for at least. That's the reason I give you all this time to practice by yourself. I was assuming that you, well, I think you should be able to do these problems if you read the slides. So here, they say at least 8. So we can take the complement. X is less than 8. So we can use the Poisson distribution. So this is the PMF, f of x equals 2. In this case, we have to do x e to the negative lambda x over x factorial. So this is the PMF, right? So you have the parameter they give you. Lambda is 8 calls, right? So in this case, basically you need to find out 1 minus the probability of x equals to 0, plus the probability of x equals to 1, and blah, 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 plus the probability of x equals to 8. Okay, actually 8 is not included, so till 7. Okay, so that's what you need to do. I'm gonna show you how to do a couple, and then you have to keep adding, and then subtract that. Whatever number you get from this parenthesis, you will need to subtract that from 1. So I'm talking about this thing, right? So I'm gonna show you how to do some of them, okay? And then you can the answer by yourself, right? And I can give you the answers in a little bit. I'm gonna put the answers in the video so you can see what it is, okay? Okay, so I have to use this distribution, right? So the first thing I need to do is what? I need to find x equals 0, right? So this implies that this is f of 0. So that will be e to a negative lambda. So the lambda here is 8 cols. So this will be negative 8, right? And by the way, this means this is the same as saying x equals to 0, right? So this is e to the negative lambda, which is negative 8. Lambda here is 8, and x we know is 0, right? Any number to the 0 is just 1. And then x factorial, so 0 factorial is just 1 as well. So this is basically, this is 1, and this is 1. So the only thing you need to do is e to the negative 8, right? For this value right here, right? So you should be able to do that. So that's for that, right? So if you do e to the negative 8, you get your answer, right? E to the negative 8. Negative 8, we'll put that 8e. Let me bring my calculator. I need to, oh, I can do it in that. Yeah, but it will take me some time to do that. Give me 1 second. Okay. So we can put this in the calculator. So let me see really quick what it is. E to negative 8, or better, stats relation. So plus some PDF. So we can do lambda, which is 0. I mean, actually 8. Lambda is 8, and x equals 0, and then you get your PMF. So you should get a very small number, right? So 3.35 and so on times 10 to the negative 4. So that's the P of x equals 0, right? So now you need to do the plus PF. P of x equals to 1 plus P of x equals to 2 and so on and so on. In the test, I would not give you anything like that, right? Because that just time consuming. Actually, from the Poisson distribution, you can also do approximation to the normal, right? But I didn't cover that, so don't worry about that. So in the test, I will give you at least 2 or 3. I would not give you anything like this, but you should be able to do this thing, right? So how you put this in the calculator? So I show you really quick. So you have to do it like this. I don't know if you can see that. Let's see. Let me see if you can see that. Okay. So you put, for the Poisson, you put second bars, and you go to Poisson PDF. You put lambda. Lambda in this case is the mean or the average, 8. The x value in this case is, we have to put 0, right? Because we're looking for, we have to do x, probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. And in this case, x equals to 0 is 0, right? And we should get this value, right? So 3.35. Now you have to do for 1. It should not be that difficult if you have a calculator, you see? And then you do 2 until you get to 7, right? 7 will be the last one. And you have to keep doing this until you add up like the x equals 0, x equals 1, x equals 2, until you get into 7. And then you add all these values. You add this plus this, right? Plus this. And then you subtract the whatever the sum is, you subtract from 1 this sum, right? And that will give you the Poisson, the answer for at least 8. Okay? So that's how you do that. And let's go back to the slide. And I will give you the answer for the other ones. So for the next one, so that's what you need to do, right? That's the idea. I will give you the answer in a little bit. So here, 3 or more. 3 or more means what? 3 or more. 3 or more means this. 3, probability of 3 or more. 3 or more. So that does not include 3. Actually, yes, it includes 3, 3 or more. So 3 or more implies this. So that means that you can do the you can do 1 minus the complement, right? 1 minus x less than 3. So that implies that this is 1 minus the probability of x of 0 plus x of 1 plus x of 2. And that's it, right? Because in this case, I don't need to include 3. That's it. And you will need to do the Poisson distribution again. P of x equals to 0, P of x equals to 1, P of x equals to 2, and the same mean or the same lambda because it's the same average, right? And that's what you need to do. 3 or more means this, right? And for the last one, they're asking you at most 7. So at most 7 means 7 or less, right? If you do the complement here, that will not help you, right? So here you will have to do directly x equals to 0 plus x equals to 1 and blah, 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 until you get x equals to 7. And that's it, right? Again, on the test, I will not give you until 7. I will give you something simpler, like maybe I give you till 3, till 2, but you need to understand when to use the distribution, right? But the Poisson distribution is very straightforward. I will give you something like this, so you should be able to do it if you remember what's the PDF. And again, you can bring your cheat sheet tomorrow to double-sided print size, right? Printer paper size, and then you should be okay. Okay, so let me give you the answers for these problems. So then after that, you can see what's going on with this thing. Let me see what is the answer for that. Please, okay. Okay, that answer. Okay. For this is 29. Okay, let's see. So for A, at least 8 calls, you should get 0.5471. For 3 or more calls, you should get 0.9863. And then at most 7 calls is supposed to be 0.4529. So you should get these values, right? When you're doing the probability, okay? You should get these values. Okay. So here, in the next question, they're asking you, the average GMT scores for the top ranked graduate schools of business are least. Check for normality, right? So this is not difficult. You can use a Pearson index coefficient of skewness, and you can find out what it is, right? You just need the mean, the median, and the standard deviation. You can use this the calculator, right? You don't need to do this by hand. So you use a calculator, and we'll give you, that will be easy for you. You don't need to do check three different kind of situations, right? Because you can use a histogram, and you can use the outlier, the IQR kind of thing. Just do the Pearson coefficient, and that will, just give you the answer fast, right? So what you need to do, sorry about that, I don't know why this didn't come out. Okay, what you need to do is you input your data, right? Like you always do. So here, clear this up. And clear this up as well. So this time you just need one column, right? So this time you need to put these values, right? So this is gonna take some time. There's a lot. So 718, 703, 703 again, 703 again, 700, 690, 695. If you're using your calculator, you should do it fast. 705, 690, 688, 676, 681, 689, 686, 691, 669, 674, 652, 680, 670, 651, 651, 637, 662, 641, 645, 645, 642, and 660, 636. Okay, so those are the 30 values. So you can do this thing, right? You go here and make sure that you delete this part because that's for expected value. So you clear that up. So that's it, L1. So that's the mean. So the mean is, the mean we have is 24,467. The median, or Q2, let's see what it is. The median is 676. And you need the sample standard deviation. Sample standard deviation is 132.4981. Let me check my mean again. 24,467, and my median should be 676. Yeah, that's what they said, right? So now we need to do this Pearson index, and then we should get our answer. Let's see what we get. If we get anything bigger than 1 or anything smaller than -1, we know that this distribution is skewed, right? If it's negative, it's skewed to the left. If it's positive, it's skewed to the right. That's very simple, right? Okay, so let me go back to the slide. And let's do this problem. Okay. Anything within 0, it's kind of normal, so don't worry about it too much. But if it's less than 81 or more than 1, then you have to do something, right? So 3, the mean is 24,467, minus the median is 676. And the standard deviation is 128, 132.4981. So let's do that. So 24,167 minus 676 times 3 divided by standard deviation 128, 132.4981. So I get 0.5570 or 0.56. So this is within normality, right? So -1, this value is between 1 and -1. So I will say that this distribution is normal, right? And if you want to, double check, you can do the Q1 minus 1.5 IQR, or you can do the Q3 plus 1.5 IQR to check maybe there's some outliers there. But that's the reason we have the index, the Pearson index of skewness, right? We can check if the distribution is normal or not. So that 0.56 is within normality. So I will say that this distribution is normal. That's it. Next problem. Here. So members of our organization, the membership in an elite organization requires a test score in the upper 30%. So this is a very easy thing to do. You have a distribution that is normal. Assume that the variable is normally distributed with mean 115 and standard deviation of 12. So they said membership if in an elite organization requires a test score in the upper 30%. So if you're talking about the upper 30%, you're talking about this area, right? This part. So that implies that you're looking for 70% probability, right? Or higher. So we're looking at least 70%. So basically we have this. So the probability of X that bigger than that is 0.7, right? We're talking about that. The probability of X, a random variable takes, it should be greater than whatever this upper part, right? So what we need to do is we need to find the X value that belongs to that, right? So we have the probability, so C equals X minus mu over sigma. You need to solve for the X value, that's what they're looking for. They give you the probability in this case, right? So this is sigma, I'm just cross multiply, okay? Plus mu equals X. So the C score is in the above the mean, right? So you're gonna use the positive C value, right? Not if you use negative, you're gonna get the wrong answer. So the mean here is what, 115, and then the sigma here is 12, and you need the C value that corresponds to the probability of 0.70, right? So that's, they're asking you greater than that, right? The upper part. So what is greater than 0.7? So you think, right? So you need to look at the table, the C table. Let me see, where is that? The C table. And you need to look for 0.70. So 0.70 is here. So that's the C value that belongs to that is 0.50, 0.50, and 0.3. You get 53, right? You get the point. So 0.53. So 0.53. I need to put that here. So the C is 0.53. I need to add those values and I get the X value that I'm looking for, right? What they said find the lowest acceptable score. So that would be the lowest acceptable score. So that would be 0.53 times 12 plus 150. So the lowest score is 121.36. You want to round it to the nearest number, it would be 121, right? Because it's less than 5, right? So that would be 121. So that's the lowest score that would enable a candidate to apply for a membership. So they must score 121. So they had to score above the mean, and that makes sense, right? If you get something less than the mean, you know that you did something wrong, right? Okay, the next problem. That's it. That's the end of that problem. So that this one, number 10, they're asking you, they say a passenger on a bus on, okay, so this is an statement. Okay, on a daily run of an express bus, the average number of passengers is 48 and the standard deviation is 3. Assume that the variable is normally distributed. So this is 48 and 3. Find the probability that the bus will have. So they're asking you for these probabilities between 36 and 40. So you need to standardize this basically, right? So this is the probability of X less than 40 minus the probability of X less than 36, right? And you need to standardize those values. So here X is 40 minus the mean. So basically you have to standardize this. X is 40 minus the mean is 48 and sigma is 3, right? And you need to find this one too. Minus C, X is 36, the mean is 48 and sigma is 3. Okay, so that's what you need to do. And you know how to do this. We did in class many times this stuff. So C equals, not equals, less than. So here we have, this is going to be negative A over 3. And here we have negative 12 over 3. So you need to find what's the probability, right? So that's just some decimals. This is negative 2.67 minus C less than, that's negative 4. This is going to be close to 1, right? Or close to 0 in this case, because this is negative. So I'm going to switch it. Okay, so 2.67. This is to the right, so I need to do it to the left. Minus 1 minus the probability of C less or equal than 4. Right? So I need to look for 1 minus probability of C, 2.67, right? I need to look at the table, 2.67, 2.67. So that's the C score, 2.67. So here is 2.6 and 7 is about here somewhere. Okay, so 2.67 is 0.9962. 0.9962. What is that? 0.9962. 0.9962. So when you subtract that, you're going to get a little number. 1 minus 0.9962, that's 0.0038, right? And then minus 1 minus the probability of C less or equal than 4. That's a very small number. Or I will say 0. Okay, so C, 4. You can use 3.999, right? So that's the, as you can see, that's close to 1, right? Very close to, or you can say 1 basically. So if we go that, 1 minus 1, that would be 0, or very close to 0. So that will not change any. I'm going to say that's 0. So this is going to be 0.38, right? So that's it. That's how you do that, the first one. Okay, so this is 0.0038. Okay, so for the next one, you need to do fewer than 42 passengers. So this is very easy. C in this case, because we standardize it, C is X minus the mean over sigma. So that's 3. C, I think we already calculated that. 86 over, oh no, we didn't. So this is 86 over 3. So this is C less than -2. This is C of 2, and this is 1 minus the probability of C less or equal than 2. So we need to look at the table. What is C less than 2? Okay, 2 is here, right? So 2 is 0.9773. 0.9773. 0.9773. 0.9773. And if you subtract that, you get your answer, right? 1 minus 0.9773, you get 0. You get 0.0227. Then the next one, more than 48 passengers. So this is C 48 minus 48. Actually, yeah, more than 48. Yeah, 48 over 48 over sigma, right? So this is going to be 0. So this is 1 minus the probability of C less or equal than 0. So that should be what? Less equal to 0. 0 is the mean, right? That should be 0.5, right? Because that's just that's exactly right in the middle. The Z score of 0 or less than 0 is 50% of the normal distribution, right? Or the standard normal distribution in this case. So this is supposed to be 0.5. But let's check. C less than 0. C less than 0. So you look 0, you see? 0 is 0.50, right? You can see that. 0.50. So let's go back. So I was right. So it's 0.5. 1 minus 0.5 is 0.5. So this is 0.5. And then the last one is between 43 and 47 passengers. 43 and 47 passengers. So again, the same thing, X less than 47 minus X less than 43. We need to standardize it. 47 minus 48. over sigma, and then minus x minus the mean over sigma. So you get negative 1 over 3, which is 0.33, minus x less than negative 5 over 3, that's 1.66, x less than negative 0.33, minus the probability of x is negative, negative 1.66, and then you can switch it again, and then 1 minus, yes, and then here the same, 1 minus. Okay, 0.33. What is 0.33? Let's check. 0.33. 0.33. 0.33, that's here, is 62.93. 62.93. 62.93. Remember 1 minus that, minus 1 minus 1.66, okay? Or 1.67, let's round it to 1.67. Okay, so 1.67, let's look at the table. 1.67, 1.67 is here. .9525. 0.9525, and then we subtract that and we get our answer. 0.3707 minus 1 minus 0.8525, we get 0.0475, subtract again, and we get 0.32. So that's the answer for this problem. So between this and that is 0.32. That's it. So that's the end of this thing, right? I went over every single question. Some questions I don't have to go over like in detail, because if I do that, I will take forever in this video, right? But please make sure you practice. So it's not that difficult. As you can see, it's very strict, very simple. Sometimes, like, the only thing it was a little bit tricky was I believe this one, because you have to do many times. But on the test, I will not ask anything like this. So it will be like little. So you will have to do maybe 3 at most or 2, right? So that will be straightforward. But you need to understand what they're asking you in the problem, right? Make sure that you review distributions, right? The probability mass functions, like the discrete probability mass functions, because of the discrete probabilities, because those are basically chapter 5, right? So you have to check multinomial, binomial, Poisson. You need to practice those, right? I give you just a study guide to give you an idea how the test will look like, right? So this is how the test will look like. And if you have any questions, please let me know. Here you can use the binomial approximation we went over in class. You should have those notes, so you should be able to do that problem, okay? But other than that, everything I went over, so you should be able to do well tomorrow, okay? If you have any questions, let me know. Have a nice day.